Okay, children. Today also have come up with some applications here. Okay, right. Good number of applications. Okay. Now, are you ready to do some more questions on wedge constraint, children? Yeah. So wedge constant means first different mass systems will be moving with different velocities. Identify with respect to ground frame. Okay. Then how many contact surfaces are there? Clear. To those contact surfaces, draw normals, that is perpendiculars. Okay. Then along those perpendiculars, find the relative velocity and equate it to 0. Equate it to 0. Nana. Got the point? Then you will get the relation and you will get the velocities. This is the procedure we did yesterday. I hope so. Okay. Now coming to the point, my dear children, let us go with one more question today. I will see how many will do that. Yeah, it is DPP, our DPP question itself. I'm giving. Already I forwarded that PDF to you. Now, let us take two wedges here. Take the diagram carefully, Nana. Two wedges are there, Nana. Here, this is a ground. Okay. On this ground, there are two wedges. This is one wedge. This angle is 37 degree. On this wedge, one more wedge is there. The wedge is lying this way. And this is a rigid support, Nana. I will show one rigid support also. This is one rigid support, just like wall ankondi. This is wedge A. This is wedge B. Okay, wedge A and wedge B, Nana. This is 37 degrees he gave. Okay, clear. Now coming to the point here. He gave the acceleration of wedge A is, wedge A acceleration he gave it as 5 meter per second square with respect to ground observer. With respect to which observer? Ground observer. And he is asking to find the acceleration of wedge B, means pink wedge. What is the acceleration of wedge B? Options are given like this. Option A is 5 meter per second square. Option B is 10 meter per second square. Option C is 0. Option D is 6.67 meter per second square. So he gave acceleration of wedge A magnitude. He is asking to find the acceleration of wedge B. You understood the question, all of you? My dear children, era question అర్థమైందా? You understood the question? 6:30 అఖిల్, ఇంద్ర తేజేష్ వీళ్ళందరూ వీడియోలు ఆఫ్ చేసుకొని ఏం చేస్తున్నారండి మీరు? నేను ఆన్ చేయమంటే ఆన్ చేస్తారా? ఇంద్ర తేజేష్, స్విచ్ ఆన్ యువర్ వీడియో. Varshit, you should also switch on your video. నేను వీడియో ఆన్ చేయమంటే ఆన్ చేయడం ఏంటారు మీరు? Right children, చూడండి, wedge A and wedge B I gave. Yes, wedge A acceleration is 5 meter per second square. He is asking to find the wedge B acceleration. Yeah, how many finished? Raise your hands. Very good. Yeah, here. Yeah. Okay, I'm observing you. Right children, let us see how to do this problem. First of all, Indra Tejesh, can you explain me with respect to ground observer how wedge A moves? Can you explain? In which direction wedge A moves? In which direction? Wedge A direction lo move avutundi. Wedge A anedi A direction lo move avutundi. You see, there are both wedges are movable there. Okay, all are smooth surfaces, both wedges are movable. Okay, you see the situation there. Okay, wedge A is restricted with a wall. Wedge A is restricted with a wall nana. అంటే wedge A అనేది ఒక వాల్ కి టచ్ అయి ఉంది చూడండి. ఓకే, ఇవి రెండు మూవ్ అవుతాయి నాన్న. బోత్ ఆఫ్ దెమ్ కెన్ మూవ్. ఓకే, ఇన్ దేర్ ఓన్ పాత్స్. వాట్ ఈస్ ద పాత్ ఆఫ్ A? కెన్ యూ సే Indra Tejesh? Yeah, A, you can see the screen upward. A. A direction లో మూవ్ అవుతుంది నాకు చెప్పాలి. In which direction A moves with respect to ground observer? With respect to ground observer, wedge A moves in which direction? This is my question. What is the direction? Wedge A direction లో మూవ్ అవుతుంది. Yeah, anyone in the classroom? Yeah, stand up and answer. Yeah, very good. Very good. Very good answer. Absolutely right. Wedge A moves vertically down. Etla sir? How it is possible, sir? And make doubt రావచ్చు. నాన్న, wedge B అనేది లెఫ్ట్ సైడ్ మూవ్ అవుతుంది నాన్న. ఎస్, A అనేది కిందికి మూవ్ అయిపోతుంది. రైట్ సైడ్ ఎందుకు మూవ్ కాదు A అంటే ఇట్ ఈస్ రెస్ట్రిక్టెడ్ బై ఎ వాల్ నాన్న. వాల్ తో రెస్ట్రిక్ట్ అయింది అక్కడ. అందరికి అర్థమైందా? ఎరా, wedge A moves down. Wedge A moves down, and wedge B moves towards left. అంతే కదా నాన్న. వెడ్జ్ బి గ్రౌండ్ మీద మూవ్ అవుతుంటుంది, పింక్ కలర్ వెడ్జ్ హారిజాంటల్ గా. వెడ్జ్ ఏ విల్ హ్యావ్ వెర్టికల్ మోషన్. దిస్ ఈస్ ద అబ్జర్వేషన్ వి షుడ్ డూ. ఇది చాలా ఇంపార్టెంట్ అబ్జర్వేషన్ ఈ క్వశ్చన్ లో. అర్థమైందా? ఏ అనేది వెర్టికల్ గానే మూవ్ కాగలుగుతుంది. ఇట్ కెన్ మూవ్ ఓన్లీ vertical direction only it can move like this vertically. Okay, wedge A can move. Wedge B can move horizontally. ఓకే, ఎర్త్ మీద మూవ్ కాగలుగుతుంది. ఎందుకు అంటే మీకు డౌట్ రావచ్చు, సార్ వెడ్జ్ ఏ అనేది బి మీద ఇలా జారి కిందికి రావాలి కదా సార్ అంటే, నో. ఎప్పుడు జరుగుతుంది అలా? ఈ వాల్ లేనప్పుడు, ఇఫ్ దెర్ ఈస్ నో వాల్ అండ్ ఇఫ్ పింక్ కలర్ వెడ్జ్ ఇస్ ఫిక్స్డ్, then what happens? Wedge A will come down like this. But here wedge B is movable and wedge A is restricted by a wall. By this what we can conclude? Wedge A can only move along the wall like this, downward. Wedge B will move towards left. Wedge B left moina koddi, as wedge B moves towards left, yes, wedge A just comes down and touches the earth. Got the point all of you, my dear children? Understood? యా. వెడ్జ్ బి అనేది లెఫ్ట్కి ఎందుకు మూవ్ అవుతుందంటే ఈ రెండింటి మధ్యలో నార్మల్ కాంటాక్ట్ ఫోర్స్ ఉంటుంది అన్న. ఆ నార్మల్ కాంటాక్ట్ ఫోర్స్ వల్ల మూవ్ అవుతుంది అన్న. గాట్ ద పాయింట్? ఓకే ఎరా. సో దిస్ ఈస్ ద క్వశ్చన్ ఐ గేవ్. సో ఇంద్ర తేజేష్, సింపుల్ క్వశ్చన్ అడిగితే చెప్పలేకపోతున్నావురా. బ్రెయిన్ వాడడం నేర్చుకోరా. బ్రెయిన్ వాడడం నేర్చుకో అంటున్నా. Brain, you have brain, use the brain. Yes, don't be miser in using the brain. Pisinar la undaddu brain vaadanu. Conjuse mat hona. Right, let us see here. First of all, the acceleration of A is given as this. Actually this is what? 5 minus j cap. This is A is coming down or not? Okay, so its acceleration is like this, a naught and this a naught. Whose acceleration? Pink color wedge or B wedge acceleration is towards left. So here first we identified the motion of the two wedges. A is coming vertically down, B is moving horizontally. Now we should draw a normal. Normal to whom? Normal to whom? Contact surface. ఈ కాంటాక్ట్ సర్ఫేస్ కి నార్మల్ డ్రా చేయాలన్నా. You see, have drawn a normal to this contact surface. Got the point? Is it clear or not? Understood? Amy? Yeah, I have drawn just a normal. Green color line drawn normal. Chusaru kada? Yes, I have drawn normal to that. Along this normal, yes, we should find the velocities of both A and B wedges. A wedge ki ela undi nana direction velocity? Wedge A has vertically downward acceleration. Avuna kada? Yes or no? Is it clear or not? Wedge A has vertically downward direction. So what we should do is here, wedge A acceleration is like this. Entanana 5 meter per second square. But we need component along this green line. Avuna kada? Component of wedge A di B di rendit accelerations, both the accelerations we should find along this green line. Yes, normal line. This normal line undi kada. In normal line, along this normal line we should find the accelerations of both wedges A and B. Wedge A has acceleration vertically downward and wedge B has acceleration in which direction beta? Towards left like this, A naught. Avuna kada? So we need A naught component along the normal line and 5 meter per second square also along the normal line. ఈ డైరెక్షన్ ని నేను ఏం తీసుకుంటున్నాను అంటే నాన్న టీటా క్యాప్ అని తీసుకుంటున్నాను. ఈ డైరెక్షన్ నేను తీసుకుంటున్నాను మైనస్ టీటా క్యాప్. ఓకే, నౌ we should find the acceleration of both the wedges along this normal line. You see, my dear children, if this is 37 degree, this will become 53 degree. If this becomes 53 degree, this also becomes 53 degree. Then this becomes 37 degree. Yes or no? Okay? Is it clear? Right. My dear children. Okay. What is this angle? Can you see? This wedge angle 37 అయితే wedge కి నార్మల్ గా ఉని yes ground కి నార్మల్ మధ్యలో ఉన్న యాంగిల్ ఎంత ఉంటుందన్న? You take one wedge like this. Yeah, you take one wedge like this. You take one normal to this and you take one normal to the ground. If this is theta, this is also theta. I said or not already? Yeah. If this is 37, this also becomes, this will become what? Same 37. Is it clear or not? Enana? Yeah, very good. So this green line, normal line will make with vertical 37. అంటే vertical తో ఎంత చేస్తుంది నార్మల్ లైన్? 37 చేస్తుంది. అవునా కాదా? ఇప్పుడు ఇంత how much it becomes? 53. 37 plus 53 is 90 na? Yes or no, my dear children? Is it clear or not? Now A naught component along the normal. A naught component along the normal means what? A naught is like this. Normal is like this. This is 53 degrees. This is A naught. What is its component along the normal? A naught cos 53. Is it clear or not? Era. In the same way, what is the component of acceleration of wedge A along the normal? This is phi kada? This is phi. What angle it is making with normal? 37. So what is the component here? Phi cos 37. Yes or no? Is it clear or not, my dear children? Okay? You are able to understand, my dear? Okay. Now, my dear children, observe carefully. Acceleration of wedge A along the normal. Enta cheppandana? Along the normal enta ochindi acceleration of wedge A? Don't say 5 meter per second square. Phi cos 37. Phi cos 37 theta cap. In this direction theta cap na, this direction is theta cap I take it. Acceleration of B along the normal. Wedge B ante pink color wedge. Don't say A naught. A naught is its total acceleration. Avuna kada? Its component along the normal is how much? A naught cos 53. A naught cos 53 theta cap. Relative acceleration, that is acceleration of A with respect to B along perpendicular direction, is a null vector. This is wedge constant. Means what we will get? Acceleration of A perpendicular minus acceleration of B perpendicular is equal null vector. So phi cos 37 कितने निकलते यार? How much it is? 4 theta cap minus cos 53 means sin 37. 3 A naught by phi theta cap is equals null vector. I can write it as 0 theta cap. Sir, how you can write? Means null vector direction is arbitrary. We can take any direction. So equating the theta cap coefficients, we get what we get. Equating the theta cap coefficients, what we are going to get? We are going to get dairy milk? No, we are going to get answer. 4 minus 3A naught by 5 is equal 0. It implies A naught is equals 20 by 3 means what? 6.67 meter per second square. Issue is simple or not? A naught is whose acceleration? A naught everything. Whose acceleration A naught is? A naught is the acceleration of the wedge B, which is on the earth. Which is on the earth. Got the point, my dear children? Yes, please make it. Please make it. Okay, are you making a note of it? Yeah. This is a question from our DPP only now. Interesting, na? Same procedure we should go with. There is no change in the procedures. First, different mass systems will be moving with different accelerations and different velocities. Identify them, those directions. If you are not in a position to identify those directions, take x and y components. Then, how many contact surfaces are there? You identify. You draw the normals to those contact surfaces. Along those normals, resolve the velocities and accelerations of the masses. And they take the relative velocity or relative acceleration along that normal, equate it to 0. You'll get the answer, that's all. This is wedge constant. Finished, the children? Next is also interesting question. Actually, this DPP is a wonderful opportunity to you people. Yes, clear. Use your brains and enhance your thinking skills, visualization skills, mathematical skills, okay, through this DPP. Can I clear this? Dev and Dhruti, not visible in the camera. Indra, where are your spectacles? Where is your spectacles? We should not use R. Where is your spectacles? Right. Okay, children. Now, I am giving one more question. Mostly you are supposed to do, everyone in this class can do this question. Yes, I am clearing this, my dear children. After the class, you attempt it without seeing. If you get any doubts, I am available to you. Don't worry. Okay. Yeah, let us see. Before going to this question, I will ask, I will give one mechanical system. You should answer me. What is happening? You should answer to my questions in that. Okay? Yeah, this is a ground. For this, a rod is hinged. One end of the rod is hinged. One end of the rod is hinged. like this. It is hinged. The rod is this is a rod, okay, and one end is hinged. Okay, now my dear children, answer to my question. This tip position A, what is this tip position B? This is tip position C. Yes, the rod is free to rotate about O. The rod is free to rotate about O. The rod is free to rotate about O. Then comment on the paths of particles A, B and C. Come on, Chippan. Can you comment? How many are ready to comment? Yeah, good, good. Many people are ready to comment on it. Okay. Deepu, comment on it. Oh, wait, 1 minute, 1 minute. Don't comment, please. Vivek is available for us. Yes, Vivek, can you comment on this? What is a path followed by A? What type of path? I asked path followed by the point A, point B and point C on the rod. What path they follow? Yes, straight line, parabola, ellipsoid, hyperbola, circular. ఇలాంటి ఆన్సర్స్ ఉంటాయి దానికి అంతే. Yes. Can you say, Vivek? What type of path A will follow, B will follow and C will follow? Say. Straight path. Okay. Straight path it follow. Let us see. A follows this straight path, suppose. Then the rod length should increase. Is it happening? Is it a cartoon network? Is it a cartoon network? Rod size increase aitunda. No. Then how you can say straight path? I said straight line path, ellipse, hyperbola, parabola, circle. Which path? Very simple. This rod can move like this. Ila rotate chesana. We can rotate in both the direction. When I rotate the rod, this A will follow which path? Which path A will follow? Which path? Circular path. A will follow circular path. This is the center. Clear? Okay, B also follow a circular path. Is it clear? I will demonstrate it. You see, all of you see this marker. This is blue color, black. So I need some other color. Okay. Yeah. You see, this you can see easily. I fixed this, hinged this. I hinged here. Where? You see, this I hinged. You see, I hinged it, fixed. Other end is free to move. Now, if it is moving, which path it will move? You see, which path it is moving? You see the tip of the pen. Which path it is moving? Tip of the pen is moving in which path? You see, it is moving in which path? Circle or not? Yes, just what I asked is that only, nothing more than that. Okay, it is hinged. It is hinged. A mechanism is there. Okay, clear. It is fixed like this with hinges, but it is free to move like this. Got the point, my dear children? Is it clear or not? Yeah, that's what I'm asking. Okay, you should have this observation. Okay, the path of A and B and C are concentric circles where center is at O. Center is at O. So you should have idea on this. Okay, so now I'm giving a question. Clear? Based on this, you should answer me. Okay, this question is also from your DPP only. Okay, right here. Once again, a wedge. We can't escape from these wedges, na? Huh. Let us see. This is ground. Okay, a wedge is kept here. This is a wedge. This is a wedge. Wedge B. This is a rod. It is hinged here. Okay, this is making 30° here at one moment of time. Yes, this is O. This is point A. This wedge name is B. This wedge is moving with 1 centimeter per second. Actually, 1 centimeter per second means we should write like this as per the system international. Okay, 1 centimeter per second. Okay, so here my question is here, the speed of end A of the rod at this moment. Nana, this rod will not always make 30° with the ground. It may make other angle also. If wedge moves towards some other towards left, this angle theta decreases 30°. Why, you know? If wedge B moves towards left, this rod will come down and 30° will become some 20 or 15°. Yes, depending on the motion of the B. But what is asking at this moment, when rod is making 30° with the ground, what is the velocity of point A is asking. What is the velocity of point A? At that moment, velocity of wedge B is 1 centimeter per second. Wedge B velocity is 1 centimeter per second at this moment when rod is making 30° with ground. When rod is making 30° with ground, wedge B is having 1 centimeter per second left side velocity. Then what is the velocity of point A? This is his question. Okay, I am giving 1 minute time. Please make it. Make it, all of you. Options I should provide? Completed, very good. You see how they are finishing. 2 centimeter per second. Option C is root 3 centimeter per second. Option D is 2 root 3 centimeter per second. Right. Contact surface. So he is asking the velocities of wedge B and point A. Here what we are supposed to find is, with respect to ground observer, wedge B is moving in which direction? You already gave, no need to find. And point A is moving in which direction with respect to ground observer. This is very crucial. Okay. After that, draw the common normal, resolve the components of velocities and find the relative velocity and equate it to null vector. You will get the answer. Make it. Are you doing, children? Then when you are not visible to me, Yeah, first bench children, what is happening? Hmm. You see, I can see each and every student. Okay, please be careful. Joyita Naidu, got the answer. Very simple. 1 minute, okay. आपको 1 minute दे रहे हैं हम. एक और मिनट पूछना. 1 minute के बाद एक और मिनट पूछना. Don't say 1 minute. Already your 1 minute is finished. Right. I have given the procedure also to do. Different mass systems are moving here. He is asking the velocity of wedge B and velocity of wedge point A. He is commenting on that. Velocity of wedge B we know along with the direction. Point A with respect to ground frame, point A moves in which direction? That is very important for us. Circular motion. For 8th children, I have finished circular motion. Yes, I hope so. Hmm? So 8th class children, I have finished your circular motion. Now you can apply those concepts here. By those concepts, you can say the direction of point A of the rod by the concepts of circular motion. For any type of circular motion, velocity is always perpendicular to the radius. Yes or no? In the sense of motion. Okay? Right. Let us see. I have provided you more than sufficient time. Right. Let us see, my dear children. Observe carefully. Here, in any type of circular motion, observe carefully. It may be uniform or non-uniform. This is radius. Velocity may be like this or like this. Any chance. If the particle is moving like this, anti-clockwise, this is the velocity. If the particle is moving clockwise, this is the velocity. Whatever it may be, it is perpendicular to the radius vector or not. Yes or no? Clear? V is equals to R omega theta cap. We learned, we proved it. I proved it, I hope so. This is okay. Clear. Theta cap is nothing but this theta cap. So whatever it may be, velocity is always perpendicular to radius vector. In any type of circular motion, already, yes, we have finished these concepts. I have given derivation also. How we get V is equal to R omega also I gave derivation by unit vector differentiation. Yes or no, 8th children? Yes. Right. Now coming to the point here. Here, listen carefully. First of all, what are the two mass systems here? B and don't say rod. On the rod you should take only one point, that is A. So two mass systems are wedge B and mass of that point A. Point A and wedge B are the two mass systems. So for the two mass systems, with respect to ground observer, what are the velocities? For wedge B, velocity is 1 centimeter per second horizontally towards left. Got the point? That is minus I cap. What about the velocity of point A with respect to ground observer? Anyone can say. This rod is rotating anti-clockwise like this. So velocity of point A will be in which direction? What is the radius vector here? Radius vector is nothing but length of this rod. So how the velocity should be? Perpendicular to this means this should be the direction of velocity of A, VA. This is VA. This is VB. Got the point? Now our main theme is we should find the contact surface, and to that contact surface we are supposed to draw the normal draw karna bas. Got that? Let us see. This is a common contact surface. I hope so. So for this I am drawing a normal here. This red line, have you seen? This is a normal. Is it clear, my dear children? Okay. So this is, I am taking this as theta cap, this as minus theta cap. Now my question to you is, what is the component of wedge B velocity along this red line? Wedge B velocity is there now. What is its VB? VB component along this red line is what? Sir, what nonsense you are talking, sir. VB itself is along red line, sir. Yes, you are absolutely right. Okay? VB itself is along red line. You see this pink line, 1 centimeter per second. It is along this only now. So VB along normal direction is 1 centimeter per second minus theta cap. What, Nana? Minus theta cap. Left side I have taken minus theta cap. Now wedge B velocity component, wedge B is having some velocity with respect to ground observer. Its component along the normal is this, what we got. Okay? Is this what we got? Is it clear or not? Okay? So that is a situation. And what is the velocity of a point A along this red line? That is normal. Anyone? Anyone? This is 30 degrees means this is what? 60. This is 90 now. This is 60. If this is 60, what is this angle? 30, because 90 kada nana. Pink line ki white arrow ki madhyal 90 undal. 90 should be there. 30. So this is a VA. VA. VA component. This is 30 means this is what? 60 again. Yes or no? Okay. So VA has component VA cos 60. Velocity of A along the normal is VA cos 60 minus theta cap. Got the point, my dear children? Yes or no? So now we are getting answer. We are near to answer. Velocity of A with respect to B. This is relative velocity along the normal is null vector. This is a wedge constant principle or not? So for that VA minus VB, that is along perpendicular direction, is null vector. So what do you get? VA perpendicular is what? VA cos 60 means what? VA by 2 minus theta cap minus VB perpendicular is what? 1 minus theta cap is null vector. Null vector को कैसे ले सकते हैं यार? किसी भी direction ले सकते हैं, arbitrary. So what you are going to get here? VA by 2 theta cap, you take theta cap, you see, you equate the theta cap coefficients. Minus VA by 2 plus 1 is equal 0. I am equating the theta cap coefficients. So VA is equals 2 centimeter per second. Got the point, my dear children, all of you? Is it clear or not? Very simple, na? Yes? Clear. It includes circular motion concept. Okay, already we finished. Yes or no, my dear 8th class children? Yes or no? Yes, very good, very good. Very good. How many 8th children did this question before my discussion? Raise your hands. Okay, okay, good. Okay, down your hands. Right, Nana? Don't see backward, see forward. Board is in front of you, not back side of you. Okay, right. Yeah, please make it. I hope you are getting some interest on this wedge constant. Huh? Yes or no? Yes, you will get. You will get because you are good children. That's why you'll get it. No doubt in that. थर्ड क्वेश्चन और एक क्वेश्चन लेते यार डीपीपी का क्वेश्चन लेते हैं और एक क्वेश्चन दिस क्वेश्चन इज सेम मॉडल ना व्हाट आई डिस्कस्ड प्रीवियसली राइट ओके फिनिश्ड माय डियर चिल्ड्रन राइट कैन आई क्लियर दिस राइट और एक क्वेश्चन लेते हैं हम हमारा डीपीपी से वी विल टेक वन मोर क्वेश्चन फ्रॉम आवर डीपीपी right yes again we are supposed to draw the ground ये ग्राउंड क्यों नहीं छोड़ता है सर हमको why this ground why you are not leaving this ground sir? Huh? Yes ethane Jane is getting this doubt huh? हर एक क्वेश्चन पे ग्राउंड के पीछे पड़ रहे हैं सर ग्राउंड के बिना जी सकते हैं आप नहीं ना राइट लेट अस सी हियर नाउ here three mass systems are there okay first is a rectangle shaped okay next is a wedge इसका नाम दिए थे ये इसका नाम दिए थे बी ओके right on this a small sphere or cylinder is kept okay this is the cylinder C इसका नाम ले लो C okay this is 30 degree nana okay A is given a velocity A is moving with 2 root 7 centimeter per second. This wedge is moving with root 7 centimeter per second. He is asking to find the speed of the cylinder. The speed of the cylinder. You understood? Option A is root 21 centimeter per second. Option B is root 17 centimeter per second. Option C is 7 centimeter per second. Option D is 2 root 7 centimeter per second. Got the point, my dear children? Got it? Yes. Now coming to the point. You see, yeah. Some people are raising the hand. Okay, I know that you got the answer. Please wait for other people. You see, this model was discussed, but this not exact this question. I hope so. Okay, right. You see, my dear children, how many mass systems are there here? How many mass systems? 3. Very good. One is rectangular shaped, one is the cylindrical cross sectional, that is cylinder it is. Sir, cylinder कैसे दिख रहा है, sphere जैसे दिख रहा है? It is a cross section of the cylinder what we are seeing here. Side view, right? And wedge. A, B, C. A is a rectangular block, yes, and C is a cylinder, B is inclined plane. Okay, a wedge. Three mass systems are there here. How many mass systems? Three mass systems are there. Okay, three mass systems have three different with respect to which observer? Ground observer. Don't forget this observer. Ground observer is very important. Feel that this big boss is observing everything. Okay, ground observer is. He is observing A, B and C. What is observing the velocity of A? 2 root 7 towards left horizontal. What velocity is observing the for the wedge B? What velocity is observing? Root 7 centimeter per second. That is also horizontal. Can you estimate the velocity direction of cylinder C with respect to ground observer? Anyone can estimate the exact direction? Nana, you are able to understand? Ground observer means we ourselves. We are on the ground only now. Yes. Are you aliens? Not now. Yes, we are living on the earth. Okay, we are ground observers, sitting and observing that. So use your common sense that a red color wedge, that is a rectangular block, will move. Obviously, it is moving towards left. He gave horizontal direction. Obviously, it has only scope to move along the earth surface. It can't fly. Yes, it can't dig the ground and go into that. Okay. So wedge B also, it can move only on the earth surface, horizontal direction. That's what he provided it clearly. We know the velocity, magnitude and direction of what? Rectangular block and wedge. My question is, with respect to which observer these velocities are? Ground observer. Okay. With respect to same ground observer, can you say the exact direction of velocity? Directly, can you say? No. No, we can't say. Yes. Why? You see, as this red color wedge is moving towards left, rectangular block, and this green color inclined plane also moves towards right. Okay, what happens to this sphere? It may roll down, you are thinking, it may slide down, but it will not. You think that this sphere will go down along the inclined plane. Don't think like that. Yes, the motion will be different. You see how the motion will be. Observe carefully. Observe carefully, Nana. How the motion will be. Check it once. This is inclined plane, na? This is inclined plane. This is sphere. After some time, the inclined plane will move towards right. Okay, here it has moved up to here. After some time, this sphere will be here. Sphere will be here. So what is the direction of motion? As per your estimation? No, it is moving like this. Displacement is like this. So velocity of the sphere is also in a different way. Got the point? So displacement is, this means velocity also will have like velocity of the sphere also may be like this. It will have, you can't say the specific direction. You can't estimate the exact direction. That's why displacement is in this direction means obviously velocity will be. So we can say that this is x component and this has y component. We can't say exact direction of velocity, but we can say x component is like this and y component is like this. So by seeing this sphere, you allot x component of velocity like this and y component of velocity like this. You can't say exact direction of this sphere, direction of motion. You are able to understand, my dear children? Is it clear or not? After doing this, what you are supposed to do? How many contact surfaces are there? Red and white, green and white. Two normals you should draw. Both two normals, two perpendiculars. Along those perpendiculars, you resolve these components of the velocity of A and C. Nana, you see how many normals you should draw? Two normals. At this location, you see this dotted line. This is one normal. At this location, this is one normal. Along these two normals, find the velocity components of A, B, and C. And find the relative velocity along those directions and equate to 0. Obviously, you are going to get the answer. You will get Vx and Vy. Then, what will be the total velocity of C? Under root Vx square plus Vy square. In vectors, we have learned any vector A is in this way, Ax I cap plus Ay j cap. What is the magnitude? Root of Ax square plus root of Ax square plus Ay square. Got the point, my dear children, all of you? So I am expecting everyone is going to do this question. Yes? Got the point, my dear children? Everyone is capable of doing this question. Yes? Is it clear? Okay, now? Got the point, my dear children? Already some 8th class children did this question, I know that. Okay, before my discussion itself. But remaining people also are supposed to do this question. Got the point, my dear? Okay? This is time up, Nana. Your parents are waiting outside. Okay, I am able to listen the horns. Okay? So, let us terminate this session. Thank you, and we shall continue this discussion tomorrow. Before that, you try it, you give your best and come back to the class. Okay? Thank you, children.